start. I hope everybody will be able to understand me. Before I start, I'd like to get to know you more. I assume that most of you probably are not developers, so can you please raise your hands up who is being involved into the development, doing code, understanding some technical details of technology and programming languages? Kind of third part. And whoever did some technical stuff for Bitcoin or cryptocurrencies? Just 3 people. Okay, I will try to explain that more because today I would like to talk about what can be done with a Bitcoin Lightning Network other than just simple cases of programmable money. Because we all heard that the new generation blockchains are required to do advanced stuff, and Bitcoin is an old beast who can just be a first showcase. Today I would like to show you that actually a Bitcoin ecosystem and the ecosystem of technologies which appear around Bitcoin allows to create very complex applications with a significant robustness, inheriting robustness of Bitcoin and security model of Bitcoin, which I believe can't be done in any other existing blockchain ecosystem. So my name is Maxim Orlovsky, and I am a Chief Engineering Officer, not Chief Executive Officer, but engineering, at Pandora Core AG in Switzerland. And the company I'm working with, actually it's my company, and Olga, she is also a partner of that company. We are doing scalability solutions with layer 2 and layer 3 on top of Bitcoin network. We are investing into development of all those technologies that I will be describing today. How much time do I have? I have about 20 minutes.
As much as you want.
Well, I will try to keep it more simple and probably will skip some quite technical slides. Bitcoin is a digital programmable hard money. I don't know, did you heard about what hard money or sound money is? Maybe some of you did heard. It's economical term coming from Austrian School of Economics, and there is a very good book, Bitcoin Standard, by famous economist and I advise you to read it. It's not technical, you don't need to be an economist to understand it. And it explains in which way Bitcoin as a form of money differs from other type of money we have in availability today. And this money are built of layers. Today we all know 2 basic layers. The first part is Bitcoin blockchain. Well, Bitcoin is the name of money, but Bitcoin blockchain, to differentiate somehow as a layer of Bitcoin, that's proof of work blockchain we all know Bitcoin from, created by Satoshi Nakamoto, running proof of work consensus. And at this layer, Bitcoin as a money function as a store of value. Because fundamental problem with the blockchains doesn't scale. When you hear that somebody have created scalable blockchain, basically every time they sacrifice the decentralization property. Because they are basically building distributed databases with a few nodes, which allows you to keep a scalability. But the more transactions you have, the larger size of blockchain. And it can grow up to exabytes. And of course, it wouldn't be that any person can keep the whole history of blockchain. So if you need a decentralized blockchain, you will be limited in the scalability. So you wouldn't be able to transact a lot, and the cost of the transaction will be high. You all probably heard talks of Giacomo Zucco. He spent a lot of time explaining these things. So the bottom line is that at blockchain level, Bitcoin doesn't scale in the amount of transactions. That's why it's a good store of value, but it is not a means of payment. With the Lightning Network, the network on top of Bitcoin blockchain, which is called the layer 2, we are able to use Bitcoin as a means of payment. We can pay for a coffee, and the cost of transaction and the speed of transaction would be very low, and we can create a multiple micro payments, like paying less than a cent for a kilobyte of data, used data or something like that. Or maybe in some future with advanced smart city technologies, you will be paying by meter or kilometer of the road while your car is passing. You will be using Lightning payments to pay for the actual consumed distance. And together, these two layers, they render Bitcoin also as a unit of account. So all three important money properties, store of value, means of payment, and unit of accounting are coming together, making Bitcoin really efficient form of digital programmable money. However, there is more to Bitcoin than just money. At the same two levels, we can look a bit different than that. At Bitcoin blockchain level, we have economically secured trustless timestamp. Because blockchain is actually a time chain. It was a term used by Satoshi Nakamoto, time chain. That's another way of describing it. It's basically a time ordering of transactions, which wouldn't be changed in the future. Probabilistically wouldn't be changed. And also, on the layer of Lightning Network, we have a very interesting technology of Lightning Network onion routing. It is economically incentivized private messaging system, where you pay for the delivery of the message, and you are guaranteed that if you paid, the message was actually delivered to recipient in a very private, like in Tor network, encrypted way. And this allows to talk about not just Bitcoin as money, but Bitcoin protocol and Lightning Network protocols as a set of technologies creating an ecosystem, enabling a new level of smart contracts. And Giacomo also coined this term LMP2P as an analogy to TCP/IP stack. And if with the TCP/IP you create an internet, with the LMP2P you create a new type of economy joined with a technological layer to create the things I will be talking today. What it allows? It allows very complex forms of escrowed smart contracts. It allows to create chains of interconnected smart contracts in form of payment channels. And Lightning Network is not the only way we can do a payment channel. You can have a very rich state outside of Bitcoin blockchain. Like one of the promises of Ethereum was that we will be able to do really powerful smart contracts, and these smart contracts require a lot of state data, not just accounts, not just balances, but other types of states to be saved. And they save this data into blockchain, which doesn't scale. Here we can put the same state outside of Bitcoin blockchain and just leverage security model of Bitcoin and Bitcoin as money, not consuming the space. I will talk about that. And also there is a lot of additional cryptographic tools to create proof of storage or computing, which I will be also presenting here. Together, this unlocks a way to decentralize such things as financial digital assets. Decentralized assets are tokenized goods exchanged in a decentralized way. The stuff that is called DEX. When you have not a central exchange service, but you can do it on peer-to-peer basis, being guaranteed that the atomicity of your transaction. Storage and messaging with economic guarantees. And computing, including forms of high-load computing like machine learning tasks. This all can be done on top of Bitcoin and Lightning Network. It can be done today. And these projects have their own name. The first one is RGB. It is financial, it's digital assets on top of Bitcoin. The centralized exchange of those assets is Spectrum. Storage and messaging with economic guarantees is Storm, which stands for storage and messaging. And computing and machine learning, it is Prometheus project. What we can leverage from the Bitcoin technologies, there is a lot of acronyms here, sorry, they're really technical, but I'm just giving you an overview that different pieces of Bitcoin and Lightning Network technologies can be leveraged to build a more complex solution composed of those pieces. These pieces are ability to use unspent outputs as indicators that something has not changed. For instance, you can have agreement between parties that this particular bit output containing Bitcoin is associated with some data, and these data are valid until it is not spent. When it's spent, when it is spent, it means that these data are not valid anymore, and you need to look into some other data associated with another unspent Bitcoin output. So, outside of people who are you sharing this data with, nobody will be ever able, people with whom you are sharing the same state, you're able to prove each other the actual state of the system. Timestamping, which is another quite famous concept by Peter Todd, different time-locked transaction outputs where you can allocate some funds and you wouldn't be able to withdraw them until some time of the future, but you can create other conditions how you can withdraw them by mutual agreement with other parties. So basically you say that I will lock these funds for a month, and I will try to reach an agreement with you how to spend them. If I wouldn't reach that agreement, I will be able to take them out, but only after a month of time. Hash time-locked contracts, which are the basis of Lightning Network. SIG hash will input another technology that allows you to spend not particular output, but you can spend any bitcoins coming from any output matching some specific conditions. Onion routing in Lightning Network, special extensions added to Lightning Network messages that allows you to add arbitrary data into them, and probabilistic checkable proofs, which is form of zero-knowledge technology. And out of these pieces, we can build three main concepts I will be describing in more details. Single-use seals. We call this open seals, like open timestamps. It is a rich state outside of blockchain. It's like Ethereum sharding made in the right way. Pre-staking, where you allocate some stake, you put something at stake to guarantee that you will perform the service and you wouldn't be Byzantine node. And you're not creating that stake to run a blockchain, you're creating that stake to prove the quality of your service. And it's kind of proof of stake made it right. It's not a proof of stake actually, but I'm showing you that by taking these ideas from blockchain level and bringing them on layer 2 or 3, you actually solve problems of scalability and security, which is created by them and can be solved as of today. And utilize them to achieve the real economic result, as like providing the quality of service in a trustless way. And escrowed smart contracts, escrowed contract chains, like smart contracts made right. You don't need a Turing completeness to do very complex scenarios. And that's why I'm saying that LNP technology stack is Ethereum 2.0 made right, because it delivers that promises in a more robust way, not reinventing the wheel and starting from the chain level, but leveraging existing Bitcoin infrastructure. I need to give you a disclaimer that everything that is shown here is a work in progress. It's early stage development protocols and they can change in the future, but I would like to give you a glance of what happens inside the Bitcoin community much beyond simple use cases as of Bitcoin as mine. So I will start with the single-use seals. They will be probably called open seals or unique bits. We don't know, it was a proposal of Peter to call them unique bits, but I think there will be some discussion which name would be better. What they are? They were proposed, it was an idea of Peter Todd. He expressed it like 2 years ago. And basically it is a further development of his ideas on open timestamps and proof of publication. Right now they are developed as a part of RGB project, which aims to bring digital assets in a tokenized form on Bitcoin blockchain. And this project is led by Bitfinex, who is aiming to put USB Tether on top of Lightning Network. And with the development of this technology, because it's used by these assets, it was basically refactored as a standalone piece of tech because it can be used for other use cases as well. And at this moment, I'm leading the technological development for this project. That's why I will be spending most of the time describing how it works. So, as I described, you have this unspent transactions output. And you can say that you allocate some state to that transaction output. And this state is described basically that you just name this transaction outputs and say that until they are not spent, these particular state data are valid. And also, you can have some metadata. For instance, you can say that until this transaction output is not spent, I allocate some number of assets to this output, and they will go to whoever will be in control of the next proof. And this next proof will be created at the moment by me when I will spend this output. Here it looks like this. So you have a transactions consisting of input parts. I'm leaving it just empty because it doesn't matter where the input is coming from actually, and output part on the right side. You can have several outputs, and from the proof you can point different transaction outputs from different transactions and allocate some state and metadata to them. However, you need to make sure, because I can create one proof, you can create other point the same transaction outputs. There is no actual proof of the uniqueness of this data. That's why you are creating a cryptographic hash of this proof and tweak a public key of some other output which is controlled by you with the hash of this output. It's named pay-to-contract commitment, and the idea is that you can, with the public keys and private keys, you can do arithmetics. You can add some values to that. And the magic is that if you add some value to a public key and add the same value to a private key, you will have a new pair of corresponding keys. So you're just using a hash of some data as a value you are adding to the key. And by that, you are proving that there could be only a single proof committed to this transaction, because there could be only a single proof corresponding to this hash. And at the moment, when you have to spend some of the outputs sealed with a sealed state, you create another proof and you have to commit it into the transaction that is spending that output. So you create a chain of proofs running through transactions in blockchain. And if you are just a Bitcoin user, you don't see that there is some commitment inside of here, because it looks like any other public key. And you are unable to even guess that something is going here. But when you have access to the proofs, you can prove that there is some state changes, a history of state changes, and there could be only single state changes history. You can't double spend or do something with that. And security model is connected into the security model of Bitcoin itself. And you can create very complex scenarios like multi-sig wallets, not on this level, but by simply allocating some assets to transaction outputs controlled by a multi-sig wallet. So these assets can be spent only by those people who can spend these Bitcoins, by the same rules. And by that, you are binding the model of the assets and the model of Bitcoin security. And at the end of the day, you have this proof chain where proofs are basically link different transactions together, and they create, through the blockchain of Bitcoin, they create a sequence of the history. And this sequence can be even growing like a tree, and at the end of the day, it can be mixing different proofs from different chains, and you finally ending up with a DAG, the directly acyclic graph. So we talked about IOTA projects and other DAG-type projects. So basically, you can do a DAG on top of Bitcoin itself, inheriting the security from Bitcoin. And you don't need to solve all those problems of scalability and security and Byzantine attacks. Main properties of these single-use seals. Well, you don't consume any blockchain space at all. You just use cryptography magic to tweak some public keys, but they use the same amount of bytes in the blockchain. You add data, you add information without adding bytes. And you get an ultimate privacy, because outside of people who has the source of these proofs, nobody will ever know that something is attached to that transactions. And this means that miners wouldn't be able to censor transactions which are related to transfer of assets. For instance, one of the critics for tokenization of assets is that you know that financial assets today, their total valuation is higher than the monetary base, like N2 or N1. You have multiple trillions of financial assets, and you still have like trillions only of United States dollars. And if you will have on Bitcoin blockchain all the assets of the world, they will be more valued than the Bitcoin itself, even if Bitcoin would be only a single form of money. And miners can earn more just by censoring the financial transactions on top of Bitcoin and not complying with Bitcoin rules. So you create economical distortion of any centralization, because the value of the structure you're building on top of Bitcoin is bigger than the value of Bitcoin itself. And with this mechanism, you can avoid that problem, because miners don't know which is the value associated with these assets. And they don't know that there is any assets at all. And you even is not able to compute the value of all assets on top of Bitcoin, because it's like all in the private space. And the problem of blockchains is that everybody sees what is going on blockchain. Here, only those who have those assets, they can see that. Of course, you can publish the information to regulators or expose it publicly if you would like to, but you have option of not doing that if you would like to keep the data private. And this actually can't be done with any blockchain itself. Use cases. Well, the main use case for this single-use seal is digital assets, which I was already talking about. However, there are some other use cases. You can create a distributed randomness protocol where the randomness is created by multiple parties. You can create historical records for some audits, like health records, and you can prove the history of the health records. And you don't need to invent a new blockchain for that, because this type of things is the main use case for corporate blockchains. And with the corporate blockchains, you instantly get a lot of problems, like if you publish something on blockchain, everybody can see you need to make blockchain private, and private blockchain is actually a distributed database, why do you need to call it blockchain, and so forth. Here, you utilize Bitcoin blockchain, you spend $0 because you are not adding a data to there, you are not increasing the size of the transactions, and you still have privacy guarantees and security guarantees. You can even build solutions like decentralized GitHub, because Git is decentralized itself, but issues and pull requests on GitHub, you have a lot of comments there, and they are all centralized, stored in centralized way. You can use the same single-use seals mechanism to be sure that you have the last comments and the whole comment history, and this comment history can't change, and many other use cases. So that's just one piece of the technology, single-use seals. I will briefly cover a few others. They are much more complex, so I wouldn't be trying to explain all of the details, but I will give you just an impression what can be done this year. I will start with probabilistic checkable proofs. It is one of the zero-knowledge technologies, and this is computer science concept been known for decades, much before Bitcoin. And however, when they are combined with the smart contracts, with the escrows, they allow you to prove some complex things that can't be proven on blockchain level. So for instance, with a probabilistic checkable proof, you can prove that you are storing some data for some period of time. You can't put that into even Ethereum itself. You can't put that into program code. Or you can prove that you have done a correct computing on some complex program, like very advanced neural network, and the parties do not need to run the whole neural network to check that your computations are correct. They can use this probabilistically checkable proof to spend like logarithmically less time to be able to find the correctness of your computation. So how it works? You have some source data. This can be as steps of the computations, as a state at each of the steps. Or it could be a big file on the disk. You split this data in some way into pieces, okay, steps of the computation or some chunks of this file. And you create a merkleized tree out of these pieces. And then when you have a Merkle root, you compute a hash of that Merkle root. And this is random number. You can't predict this number by, you can't get some specific number by just constructing a source data. It's like proof of work. You just need to iterate until you will get the number that you need to. So you can measure the probability that these data are not fake. And you use this random data to extract pieces of this data together with the Merkle path to the root, and you show that as a proof. So if it is a computation steps, the verifier needs just to check these 3 steps out of whole computation, and he will mathematically know that with a 99.9995% guarantee, the whole computation is correct. Or if you are storing data for somebody, you can show this as a proof that you are keeping storing the data, and you didn't just discard them. And still, you are not providing the whole data until you are not paid for the storage. So you're proving that you have the data, but you are not allowing other party to run out with those data without paying. And these are basically main 2 use cases. Data storage proof, which are used in the Storm project, and computational integrity arguments, which allow you to scale the computation by just creating very compact proofs. The other part of the technology is a chain of escrow smart contracts. Like in Storm, with this incentivized storage and messaging, we can have a very simple use case. Bob stores data for Alice. Alice don't have enough disk space, and she asked Bob to store those data. She doesn't know Bob directly. Maybe she doesn't trust him. And Alice puts payment, and Bob puts stake under escrow time-locked contract. So they together putting some money. Alice, it will be a payment to Bob if Bob will keep this data, and Bob will give this stake back to Alice if he wasn't able to keep this data as a kind of compensation. And they are all locked for like a year time. And they have this, they create this funding transaction. Here is money from Alice, it's a payment. Here is money from Bob, it is his stake. And they have 2 options to spend that data. Either by mutual agreement, so they both sign that they agree that everything is fine, or after some time, Bob takes all the money because Alice didn't provide it. Bob takes all the money because Alice never came asking for that data back. And still he needs to get back his stake and his payment. Then they presign partial transactions, not publishing them like in Lightning Network, for different scenarios. I wouldn't go into all the details. These are 3 of the transactions which are not going to blockchain. At the end of the day, there could be only a single transaction published when they negotiate through all these stages. But they use these transactions to be sure that in a trustless environment, they still will get their payments no matter what will happen to the other party, and the other party can't cheat. So, if Alice forgets about the data, Bob still takes the payment for the storage. If Bob fails to prove that he has had the data, Alice takes the money back and plus Bob's stake as a compensation. If Alice fakes that the Bob proof is not correct, Bob still can prove on-chain that he has had the data and take back his stake and part of the Alice payment or even all Alice payment. They negotiate at the beginning of the contract which guarantees they are happy with together. And in cooperative scenario, when Bob he takes his payment, he reveals an encryption key which allows Alice to access the data which was stored by Bob. So here is some idea how these transactions are combined with probabilistic checkable proofs and the sequence of actions. But at the end of the day, we have a scenario when Bob is sure that he will be paid if he keeps the data, and Alice is sure that the data will be kept in security, or he will be compensated with some amount, she will be compensated with some amount of money she's fine with. And she can use like not a single block, but 10 different blocks to store her data, and in that way she can ensure that the data will be safe if the data are really important to her. The next technology is multi-body state channels. It's the last one. So I assume that you're really tight. And we use that to create Prometheus protocol for computing and machine learning on top of Bitcoin. The case is quite simple. Well, Alice orders some computing from Bob. They agree that Carol will partially verify with these probabilistic checkable proofs results of the computing. And they also agree on some arbiter who will be able to solve in the case that they are not reaching the same agreement, Alice, Bob, and the verifier. Alice puts her payment for computing, and the other participants put their stake. And they created actually 8 different transactions interlinked together. Only 2 of those transactions are published. And these transactions work in the way that there is only 7 possible outcomes, how somebody tried to cheat someone, and they are all covered by different transactions output, so each path leads us to a settlement that is fair. So nobody can cheat without paying some of his stake. So these are just a glimpse of what can be done with a Bitcoin Enlightenment network. There is much more about behind that, like you can have open arbitrages as the highest court when you have some complex case and you need to take a decision on that, and you allow all the parties who is interested to join the arbitrage and express his opinion by putting something at stake. And you have, like for instance, a month's time, and everybody who is registered with a stake as an arbiter before the start of arbitration, they can join this arbitration process and they can vote. And if they would not reach a final verdict, like 50 on 50, and you need 75 on 25 to take a decision, they all lose some or all of their stake. So basically you can play an economical game in trustless environment to get something like a court decision with a, I don't know this English word that you have in court, just 12 randomly selected people voting for who is guilty and who is not. This is the same done with Bitcoin. You can have more complex trustless computing scenarios. You can have a distributed multi-party randomness. You can have decentralized exchanges. You can have even smart contracts with new type of scripting languages which can't expand Bitcoin functionality, but they can narrow down the cases of how you can spend financial assets or something else. And multi-party payment channels, because Lightning is a peer-to-peer payment channel with 2 parties between 2 parties, but you can create multi-party payment channels as well. If you'd like to see more about that, you can look at these GitHub repositories, and we are working on implementation of all that gradually. So we are at this moment we are focusing on open seals and RGB, and after that we will be moving to doing other pieces of technologies. Other participants of the protocol development, of this protocol development, include Peter Todd, Bitfinex, CHB Network, Giacomo Zucco, and Bitcoin from Italy, Chainside. We have Federica here. Poseidon Group, Fulgur Ventures, Hyper Division from Copenhagen, and many others. So we are welcoming you to join the network on these projects. And if somebody would like to contact me, you can do it to my social medias or email.
Thank you very much for.
Probably questions, or we can proceed to the next speaker directly.
5 minutes break.
Oh,
Let's
okay.
have a break. Okay.